Welcome back. This video is for study session 2, Introduction to Algorithms. After you must have studied this study session, you should be able to explain what you understand by algorithms. You should be able to discuss the characteristics and properties of an algorithm. You should be able to discuss pseudocodes and flowcharts and how they are used to represent algorithms. What is an algorithm? Algorithm is an active method conveyed as a fixed list of well-defined instructions for computing a function. Algorithm is a step-by-step method for solving a problem or doing a task. An algorithm is a written or verbal description of a logical sequence of actions applied to objects. We use algorithms every day, like recipes, instructions, and even directions. They are all examples of algorithms that are not programs. An algorithm is a well-defined computational procedure consisting of a set of instructions that takes some value or set of values as input and produces some value or set of values as output. In other words, an algorithm is a procedure that accepts data, manipulates them, following the prescribed steps so as to eventually fill the required unknown with the desired values. Now, there are certain terms in algorithm. Let's define them. Finiteness. The algorithm must always terminate after a finite number of steps. Definiteness. Each step must be precisely defined. The actions to be carried out must be rigorously and unambiguously specified for each case. Then we have inputs. An algorithm has 0 or more inputs taken from a specified set of objects. Then we have outputs. An algorithm has 1 or more outputs which have a specified relation to the inputs. Then the last but not the least is effectiveness. All operations to be performed must be sufficiently basic that they can be done exactly and in finite length. Then let's look at characteristics of an algorithm. Number 1, each step of an algorithm must be exact. This goes without saying. An algorithm must be precisely and unambiguously described so that there remains no uncertainty. Number 2, an algorithm must terminate. The ultimate purpose of an algorithm is to solve a problem. If the program does not stop when executed, we will not be able to get any result from it. Therefore, an algorithm must contain a finite number of steps in its execution. Note that an algorithm that merely contains a finite number of steps may not terminate during execution due to the presence of infinite loop. You will know more about an infinite loop later in your course of study. Number 3, an algorithm must be effective. Again, this goes without saying. An algorithm must provide the correct answer to the problem. Number 4, an algorithm must be general. This means that it must solve every instance of the problem. For example, a program that computes the area of a rectangle should work on all possible dimensions of the rectangle within the limits of the programming language and the machine. These are the 4 characteristics of an algorithm. Now, let's look at pseudocodes and flowcharts. Algorithms can be presented in the method of some pseudocode, which is normally a mixture of English statements, some mathematical notations, and selected keywords from a programming language. There is no standard convention for writing pseudocode. Each author may have his own style as long as clarity is ensured. Now, what is a flowchart? A flowchart consists of special geometric symbols connected by arrows. Within each symbol is a phrase presenting the activity of that step. The shape of the symbol indicates the type of operation that is to occur. For example, the parallelogram denotes input or output. The arrow connecting the symbols are called flow lines, and they show the progression in which the steps take place. Let's look at these symbols, their names and the meaning. You see the symbol arrow, that's a flow line, that's the name. The meaning is that it's used to connect symbols and indicate the flow of logic. Then we have the rectangle, which is the terminal. We have the parallelogram, which is the input and output. Then we have the processing, we have the decision. We even have the connector. These are the symbols that are used for flowcharts in programming. Thank you for listening. This is the end of the class. See you in the next class.